Hello, intermediate algebra students. This is Miss Krupstad, and we are going to go through a video today that talks about 9-6, which is the discriminant and the quadratic formula. 9-6 is the very last section in topic 9. We will be taking our test a week from today, so make sure to pay attention, take good notes, and be ready to ask questions if you have any tomorrow. First, I want to just kind of go over what you were doing this video through, which is an Edpuzzle. An Edpuzzle, if you haven't done one before, is a system where I can ask you questions periodically throughout the video. You cannot skip through the video or fast forward through the video. And also, if you navigate away from the video or go to a different tab, the video will stop playing. The notes can only be found by watching this video today. And all I ask is that you do your best and you be your best. This needs to be completed before the end of the school day today. If you have questions about this video, I will answer them during our next class, and this will be entered into the gradebook as a formative grade. Many of you sometimes already check out when videos are required for you to watch or asked of you to watch. This is kind of a way where we're making sure that you don't just not do it. I would like for you to give your best and try your best in order to try to understand the content that you're learning today, because you are all very, very capable. In order to be prepared for today, I would highly recommend you open your notes to page 8. That's your yellow packet. Page 8 should contain the 9-6 notes about the discriminant and the quadratic formula. You also might want to grab a piece of scratch paper, or you could use the very back of your packet, because as I ask you questions throughout the video, you might want to write some things down to, understand what you're thinking about. All right, let's get started. So today, because it is the last section, we are going to be learning the very last method for how to solve a quadratic equation. So far, we've learned how to solve a quadratic equation by using a graphing calculator, which we use both the table and the graph to figure that out. We have used factoring, which was the box method. And then we've also used square roots, and we've used square roots in a couple different types of problems. But sometimes none of these are a really great option. Sometimes an equation is set up where I cannot take the square root to find the solution. Sometimes an equation is not factorable. Sometimes I don't have a graphing calculator, or it's just tedious to plug that in. So there has to be another way to find the solution to a quadratic. Enter in this big formula called the quadratic formula. If you were to ask your parents if they remember this formula, I bet you many of them might actually say they've seen it before, because this is a very common formula taught in high school. This formula allows us to find the solution of any quadratic equation that is written in standard form, ax squared plus bx plus c. Note, your equation does have to be equal to 0 in order to use this formula. A formula is just something that we plug values into and it gives us the answer. There's quite a bit of crazy stuff going on in this formula, and we'll come back to the whole formula in just a little bit, but we're going to start with just a piece of this formula. It is the stuff that is underneath the square root. This is called the discriminant. The discriminant is just b squared minus 4 times a times c. Then we're going to start with the discriminant is because it actually tells us some pretty important things about the solutions to our quadratic equation. If the discriminant ends up being a positive number, what that means is, here's the quadratic formula simplified down, is for instance, if I had like 125 there, since this is the number that's underneath the square root, we would end up getting two solutions, right? We would have one where I was adding the square root of 125 and one where I was subtracting the square root of 125. The square root of 125, although it is not a nice number, aka it would give us a decimal of some kind, it still exists. So when we have a positive discriminant, we end up getting two real solutions. When I say real, I mean values that actually exist. There are such numbers where they don't actually exist, and we'll talk about that later. So when your discriminant is positive, we know we are going to get two real solutions to the equation. Now, here's another situation. If that discriminant, or that b squared minus 4ac value, is 0, something else interesting happens. We get the square root of 0. Well, I can think the same way, right? One is going to be plus the square root of 0, and one is going to be minus the square root of 0. But the square root of 0 is just 0. So adding 0 and subtracting 0 gives me the exact same answer, which is negative b divided by 2a, or opposite of b divided by 2a. In which case, we get one real solution. We don't get that situation where we have one adding and one subtracting, because it's adding and subtracting 0. Now the last situation, see, is the negative discriminant. So if we had the quadratic formula and we had a negative number underneath the square root. We've talked about this a little bit in class, but you can't take the square root of negative numbers. For instance, in order to get a negative 9, I would have to have one number being a positive 3 and one number being a negative 3. It is never possible to have two numbers that are exactly the same that give me a negative value. So when we have a negative number underneath the square root, this is not even possible. So we say there are no real solutions. So that's what we're going to start with figuring out today. We're going to figure out, are there two solutions, one solution, or no solutions to the equation? So in your notes, you can write down that the discriminant is b squared minus 4ac. Now, if you would like to, you could add symbols in there that would help you out so that when you're plugging things in, you get nicer answers. So for instance, a lot of times I will put parentheses around the B, the A, and the C so that I know when I'm squaring something, when I'm multiplying something, and how I need to plug it into my calculator if you're going to choose to use that. The discriminant tells you how many solutions or x-intercepts a quadratic will have. Now, I didn't talk specifically about x-intercepts, but if you remember back way in the beginning of this unit, we talked through the fact that you could have a graph that never crosses the x-axis. This would be a situation where we have no solutions. We could have a graph that crosses the x-axis one spot. That's where you would have one solution, and we could have a quadratic function that crosses in two spots. So, and that would give us two real solutions. So x-intercepts are the same thing as solutions. If the discriminant is positive, you get two real solutions. If the discriminant is negative, you get no real solutions. And that's because you can't take the square root of a negative. And if the discriminant is 0, you get one real solution. If you need to, you can pause this video to continue writing those notes. All right, so we're going to go through an example together, and then I will do some more examples where you have to answer some questions. Let's start with one together, though. So first, find the discriminant and use it to determine how many solutions there will be to this quadratic equation. The first thing I want to point out is that we already have this in standard form. We have it equal to 0, which is a good thing. And since it's in standard form, we can identify that A is 2, B is 7, and C is negative 10. Once we know those values, we can plug those into the equation for the discriminant, which is over here on the right-hand side. So I have B squared minus 4 times A times C. So B squared minus 4 times A times C. I'm going to replace those with the values that I have in my equation. So my B value is 7. My A value is 2. And my C value is negative 10. You can use a calculator to type all of this in if you would like to. My suggestion would be to make sure you're following all of the parentheses that we have written here. If you do that, you'll get the right answer. But let's talk about how we would solve this without using our calculator. The first thing that I would figure out would be 7 to the power of 2, or 7 times 7. That is 49. Then I am going to multiply. It doesn't matter what 2 we multiply, but I'll start with multiplying 4 and 2 together to give me 8. Well, I still have to multiply that by a negative 10. So now I have 49 minus 8 times negative 10 is negative 80. And when I have minus a negative, that turns it into a plus. So this gives me 129. So the discriminant in this problem is 129. What does that tell me about how many solutions I have? Well, because my discriminant is positive, I end up getting 2 real solutions. Now again, if you didn't like the method of, doing all that mental math, you don't have to do that. You can plug all of that straight into your calculator to get the answer. This time, I'm going to have you do a little bit thinking about this. First off, what is your A, your B, and your C value? Our A is 3, our B is negative 5, and our C is a positive 4. What would you get if you plugged those into the discriminant? Be careful of your parentheses. You would get the B squared minus 4 times A times C. Now, take a moment and either plug that into your calculator or do some scratch math on your scratch paper in order to figure out what is the value of the discriminant here. Again, you could have used your calculator, but if you did not and you wanted to do some of this in your head, I would square negative 5 first, which gives me a positive 25. I would multiply 4 times 3 to get 12, and then know that I still need to multiply it by that 4. Then I would get 25 minus 12 times 4 is 48, which ends up giving me a negative 23. Sorry, I had to double check. A negative 23. Negative 23 would be my discriminant, and what that tells me is I would get how many solutions? You get no solutions. You could also write 0 solutions, I suppose. I sometimes write no instead of 0 just because I don't want people to think that I think that 0 is the answer, but you get no solutions. This would be a situation where we have a graph that never crosses the x-axis. Let's try another one. All right, once again, we have something in standard form. Identify your A, your B, and your C, and then use those to plug it into the discriminant. What did you get? Did you get it all the way down to a discriminant of 0? If so, what does that mean about the number of solutions this quadratic equation has? The discriminant is 0, that means we will get one real solution. That also means that that solution is the vertex of our equation. Let's do one more together. This time I'm going to ask you to take it from beginning to end and identify what is the discriminant and how many solutions this equation will have. A discriminant of 64, which means there's 2 real solutions. If so, you did it correctly. If not, maybe you should look at the work that's posted here so that you can check and see what you made a mistake on. Again, you can always use a calculator if you're having issues when you are trying to do some of this PEMDAS work or simplification work. The other thing I want to give you a clue about is I believe that this is the first problem in the back of your yellow packet. So when you turn to section 9.6 in the back for extra practice, this would be the first problem that you could copy down right now if you would like to. Now, we've been talking about how many solutions that we have in each of these quadratic equations, but we want to know what the actual answers are. I want to know what those x-intercepts are. So in order to find the solutions, we have to actually use the entire quadratic formula, but we've done most of it already. This is a formula that you do not have to memorize. There are some fun songs that go with it, which I can sing for you another time. But again, you don't have to have these memorized. You do have to know how to work with this though. So we're going to start with an example together and then we'll fill in our notes and have you try a couple on your own. All right, so here's the first equation we have. Find the solutions to the equation using the quadratic formula. Now, my equation is already in standard form. it has it equal to 0. It means that my values are all on the same side together, which means I can identify my A, my B, and my C. Oops, I made a mistake. That should be a -7. Now, I'm not going to jump straight into the quadratic equation or quadratic formula. I'm actually going to find the discriminant first. It makes it a lot easier moving forward. So I'm still going to do b squared minus 4 times a times c. My b is 3, my a is 5, and my c is -7. Through the power of magics, I can get that answer pretty quickly. The discriminant of this is 149. What that tells me is I am going to get 2 solutions at the end of all of this work. So if I don't end up with 2 answers, I probably did something wrong. We're going to continue our method of finding the actual solutions by continuing forward with this quadratic formula. We already know what this is. We are going to have to fill in what that opposite of b is, and we're going to have to fill in our a value. Oops. What this is going to look like is, wrong pen, I am going to fill in the opposite of b, I'm going to fill in the discriminant, and I'm going to fill in the 2 times a. So what that looks like, the opposite of b, in my case, is going to be a -3. My discriminant is 149. That goes underneath the square root. And then our a value is 5. From here, you are just doing a lot of simplification. Sometimes the answers are going to be nice, and sometimes the answers are not going to be so nice. What I do with starting is I am going to split this into 2 separate problems. One of them is going to be -3 plus the square root of 149 divided by 10, because 2 times 5 is 10. Then I'm going to get -3 minus the square root of 149 divided by 10. Now, if you are not sure what the square root of 149 is, you are not alone. It is not a nice square root. We can figure it out using our calculators, though. Calculator. In order to help you find that square root button I wanted to show you here, it is generally located right above the x squared button. So in order to get that square root, I'm going to have to press my second key and then that x squared button, and then I can type in whatever number I want to take the square root of. In order to get the answer, I have to press enter. Now, obviously, this is not a nice answer. We're going to just do our best to round this. So I'm going to round it to 12.2066 maybe? 12.2066. Over 10. And then in my other one, I have -3 minus 12.2066, all divided by 10. I just need to finish this out by doing that addition and subtraction and then dividing by 10. In my calculator, I can type -3 plus 12.2066. I get 9.2066. Oops, and then I have to divide that by 10, which gives me 0.92066. And in the second one, I have to do -3 minus 12.2066. And then divide that by 10, which gives me -1.52066. Now, on most of our tests and quizzes that we're going to have for this unit, we're going to want you to round to 3 decimal places. What that means is I want 3 numbers. Oops, that's black. That's not going to work very well. 3 numbers after that decimal point. In order to round appropriately, I need to look at the number that comes next. So in this case, it is a 6. The 6 tells me that I need to round this answer up. So 921. If it was less than 5, I would keep that value the same. So there are my 2 solutions to this equation. Now, it is not always going to be this complicated, but this one happened to be a little bit tricky because we did not get a nice square rootable answer. I wanted to model that for you though, because you can still plow through it using the power of your calculator. Here are the notes that I want you to take. In this first box, I want you to write down that I would really like for you guys to think of this first part as the opposite of B. We have seen something like this before when we were in our last unit. It is important to think of it as the opposite of B because it doesn't always end up being a negative number. The other thing to make note of is that this stuff underneath the square root, that is the discriminant. That is what we figured out just not too long ago. Discriminant. But that was painful for some of you. In the next part, I want you to write down that you do not include x's in the formula. The formula will only have numbers in it. That's what allows us to find what x is. And then lastly, you will round at the end if it is necessary. Sometimes it's not necessary. Let's walk you through some steps and do an example at the same time. So as we go through the steps, we're also going to be working on an example together. The example we're going to do together is 3x squared minus 11x equals 4. The very first thing you might notice here is that our equation is not in standard form. We need to make sure the quadratic is set equal to 0. So I need there to be a 0 on one of these sides. It does not matter which one. So in order to make this equal to 0, the fastest way is to subtract that 4. When we subtract 4, we cannot combine it with anything on this left-hand side, so I'm left with 3x squared minus 11x minus 4 equals 0. Now what we're going to do is we are going to use that standard form equation to find the discriminant. The discriminant is right above you in your notes, but just in case you want easy access to it in your brain, you can write it right underneath that line. So my A value here is 3, my B is negative 11, and my C is negative 4. We're going to plug those numbers into that B squared minus 4AC equation. That will leave me with negative 11 squared minus 4 times 3 times negative 4. You can do some quick mental math there if you would like to with showing all those steps, or you could plug it into your calculator. When you plug it into your calculator or get your final answer, your discriminant is 169. What that means is at the end of all this, we are going to end up with 2 solutions to this equation. All of that was kind of stuff that we have already worked on before. From here on out, we're going to be using that entire quadratic formula. So we're going to plug in the discriminant and the remaining, that's a weird E, values into the quadratic formula. Okay, as a reminder, what we are left with is they're the opposite of B plus or minus the square root of the discriminant all divided by 2a. We are going to be replacing the opposite of B, the discriminant, and that a value. Using the same numbers that we have up above, I know that my B value is negative 11, so the opposite of B will be a positive 11, plus or minus the square root of my discriminant, which is 169, all divided by 2 times my A value, which is 3. From here, we can split this up into 2 separate mini problems. One of them is 11 plus the square root of 169 divided by 6, and the other one is 11 minus the square root of 169 divided by 6. All of this is part of the simplification process. So we're going to simplify the finished formula for all solutions / x-intercepts. All right, now the square root of 169, if you are not sure, you could type it into your calculator, but I happen to know that the square root of 169 is 13. So now I have 11 plus 13 divided by 6 and 11 minus 13 divided by 6. I'm going to continue working this and simplifying it. So I get 24 divided by 6, which is 4. And then I get negative 2 divided by 6, which I can reduce to either negative 1/3, or you could write it as negative 0.3333333333. So once again, as a reminder, we knew at the very beginning from our discriminant that we were going to get two solutions, and here they are. Our solutions are 4 and negative 1/3. The last step, which again you can see it says if needed, is we will round our answer if it's needed. Here, I didn't necessarily have to round if I kept that one as a fraction. All right, let's try some more practice. Okay, so first, I want you to think about what would this equation be if I had it in standard form? I chose to write this equation in standard form by moving that 3x squared to the other side. So I got negative 3x squared plus 6x minus 3. Now you could have chosen to move the 6x and the minus 3. So there is another possible solution to this, or way of writing it in standard form, which would be 3x squared minus 6x plus 3. Either way you write this, if your equation is set equal to 0, you will get the same answer no matter what. Now, just for ease, let's use my first equation that I have written here. I want you to tell me what is the discriminant of this quadratic equation. Of this quadratic equation happens to be 0. So if you got that, congratulations. Now, what does that mean? That means that when we get our final answer, we are only going to have one solution. So the next thing I want you to think about is what are we going to be plugging in order to figure out what that one solution is? What is your next step? You should have plugged in the opposite of b, which would give you a negative 6. I messed that up. Look at, even teachers mess up. A negative 6, because it has to be the opposite of 6. My discriminant is 0, and I have to divide that by 2 times my a value, which is negative 3. From here, I want you to find what would be your one solution by simplifying that equation. We have the square root of 0. The square root of 0 is just 0. So we get negative 6 plus 0 or negative 6 minus 0, which doesn't matter because we already know we only get one solution, which ends up giving us negative 6 divided by negative 6, which is 1. Now, one of the nice things about solving quadratic equation, just to take this one step further, is you can always check your answer. If we were to plug 1 in to our original equation that we were using, and we typed that into a calculator, we should end up getting an answer of 0. Because remember, we're looking for where this function is equal to 0. And that should end up working. Here is one last problem for you to try. I'm going to just ask you at the very last, what is the solution to this equation, or solutions? Here we have to add 3 to get it equal to 0. Which leaves us with 5x squared plus 2x plus 3 equals 0. Our a is 5, our b is 2, and our c is 3. We're going to use the b squared minus 4 times a times c. And we can plug that into our calculator, or we can do a little bit of mental calculation. Did you get a discriminant of negative 56? If so, what that means is there are no solutions to this equation. You don't even have to continue solving the quadratic equation or using that quadratic formula because your discriminant tells you everything you need to know. All right, so what are you going to do now? Here are the options for the remainder of the class period. You can either complete the 9-6A and 9-6B Easy Bridge practice, or you can complete the practice problems in the back of your packet. You should be able to complete all of the problems. There's 2 application problems in 9-6 that we will talk about on Friday, but you could technically solve those right now if you would like. I will see you in class. Have a great day.